Well, we've had a shift here, and we got the autumn stars high overhead. One of them is back behind me here. We have this M group of stars in the sky. You know, earlier it was a W.
That's true.
But now it's an M, and that's because the rotation of the Earth has caused the whole sky to wheel around the North Star.
Huh.
And as it does, it changes from a W to a 3 to an M. That's the constellation of Cassiopeia,
Okay.
the queen. You're supposed to see a queen seated there. I don't really see that. And then back this way a little ways, we have the Great Square of Pegasus. It's this big rectangle.
Yes, I see
not,
that.
Not quite a square, but we call it a square. There are very few stars inside, so it really jumps out at you.
Yes.
High overhead in autumn evenings. And it's supposed to be a winged horse. This is the body of the horse and the wings sticking out here. Its head is up here like that. And out here, the two front legs. We only have the front half. We don't have the back half. But you know, I've always thought if you're going to have a half a horse,
You better have the front half.
Front half rather than the back half.
Yeah.
That's the constellation of Pegasus. Now, coming off of Pegasus is Andromeda, supposed to be a chained maiden here. Go up a couple stars, there's a little fuzzy spot right there.
I
Do you
see.
see that?
Yes, I
Now,
do.
it's best to use averted vision. You don't look right at it, but you look off to the side. And when you do that, it shows up much better. A little fuzzy patch.
Little fuzzy spot.
That's the Andromeda Galaxy. That is the most distant object that you can see with the naked eye. But it's the nearest galaxy, similar to our own galaxy. It's we think a little over 2 million light years away, and it contains a couple 100 billion stars.
Wow.
So it's a very impressive object in the sky, but you need a lot of aperture to see it well.
Yeah. Okay, Danny, that brings me to a big question, and a big question in a lot of people's minds. If we have stars that are that far away, millions of light years away, and if the Earth is young, as we believe, then how in the world can the starlight be here?
Yeah, we call this the light travel time problem, and I'll try to phrase it for you a little differently. We believe that the creation is only thousands of years old, say 6,000 years, 7,000 years, something like that. And I've just pointed out something to you that we think is 2 million light years away from us.
Right.
I think those distances are reasonably correct. You know, if it's off by 100%, it's still maybe 1 million light years. And
Right.
that isn't going to solve the problem. And by the way, this is just the closest. There are galaxies that are hundreds of millions, even billions of light years away from us. So the question is, as you ask, if the universe is only 6,000 years old, you can only see things within 6,000 light years. How can we see those distant objects? Now, it wouldn't affect most of the stars we see because they're at most a few hundred light years in most cases, or a couple thousand light years. But you know, the situation, Del, is a lot worse than you said. The situation is even worse. Let's go back to the beginning of creation. Say at the end of day 6, beginning of day 7, the sky gets dark.
Yes.
The creation's ended. Adam and Eve look up, the sun sets, the sky gets dark. What do they see? They had to see stars, because if they didn't, the stars could not fulfill their function. But the problem is the nearest star outside of the sun is more than 4 light years away. So how could Adam see the nearest stars? We're so concentrated on the most distant objects in the universe, but we really need to think about what Adam saw in the closest objects outside the solar system. If you can answer that question, that problem, then I think the problem we have today is probably answers itself.
I see that.
And we creationists need to answer this question, and we've offered several different solutions to that. I'll discuss with you my solution on this. And I came up with this a few years ago after wrestling with this for years, and I think I was looking for a scientific answer, if you will, a physical answer. But I think several things jump out at me in the creation account. One is that many people think that everything during the creation week was instantaneous. Poof, a tree appeared where there was none. Poof, a whale appears where there was none. But that's not what the text generally says. There's a lot of process going on, very rapid process, but still process. For instance, did God make Adam just poof out of nothing? Well, no, he shaped his body out of dust of the ground. What about Eve? Well, he took from his side and made Eve. That was a process in either case. It was a quick one. It didn't take, hours or days. It happened less than a day.
But it was a process.
It still was a process. If you look at the count of the animals, not on the chapter 1, but in chapter 2, it speaks of the animals coming out of the ground giving rise to these things. If you look at the day 3 account, it talks about plants rising up out of the ground. It says, let the earth bring forth these plants, and the earth brought forth. If you look at those words used there in Hebrew, they're very active, dynamic terms. It's almost like these things are sprouting up out of the ground very rapidly. I think if you would have been there, it would have looked like a time-lapse movie. You would have seen growth that might take normally decades taking place in a matter of minutes or hours at the most. Normal growth, abnormally fast. Why? Well, in another 2 to 3 days, you can have all sorts of critters and people that are going to rely upon those plants, because it turns out everybody was vegetarian to start with. And if you waited till they normally matured the way they normally do, everybody would have starved. Because, even the fastest growing garden plants take a couple of months to reach maturity. So God had to mature these things fast, rapidly. He didn't make them mature, he matured them rapidly from what the language is telling you there. I believe you can interpret one day of creation in terms of another day. So I turn to the day 4 account. Not much information is given there, but I think God also rapidly made the stars and other astronomical bodies. And then, in order for them to fulfill their function to be seen, he had to rapidly bring forth that light, just as he brought plants and matured them quickly. He had to bring that light here. Now, I'm not suggesting the light was created in transit. That's one theory. You see, if you have light created in transit, the light we're getting from these distant objects didn't come from physical processes. It's like they were holograms or just illusions. I'm suggesting when we actually look at these objects, like the Andromeda Galaxy we saw a few minutes ago, we're looking at light that actually left that object. I believe that the Andromeda Galaxy is about 2 million light years away, but I don't for a minute think that the light has been traveling that long. I think we're looking at the universe in something close to real time. If the light's only a few thousand years old instead of a couple of million years old, well, that's pretty close to real time. So I think there's a rapid maturing took place. Also, I'm not appealing to a physical mechanism. I'm appealing to a miraculous. And some of my creation science buddies have given me a little bit of grief on this, because they're looking for scientific answers for everything. And you can give scientific answers so far back. But the writer of Hebrews, and also Paul writing to the Colossians, talked about the current sustaining of this world by the power of his word. Moment by moment, the Lord sustains this world. I don't know how he does it. Maybe it's miraculous, but he does it in a consistent pattern, the way that God does things. He does them consistently and orderly. And we can study that. In fact, we can write equations that describe it. These equations we have, it's called physics. And so the study of physics is really the study of how the world is being sustained moment by moment. But you can't take that sustaining and extrapolate it back into the past, because eventually you'll bump up against creation in the past. And creation is a miracle. There's a certain point where the miraculous take place. And I think at some point, maybe it's stages, but certainly by the end of the creation week, God went from creating to sustaining. And if we try to push back the current sustaining, what we call physics, into the creation week too far, we're kind of committing the uniformitarian assumption. We accuse the evolutionists of. And I think sometimes we seriously underestimate how the miracle of creation, we might as well come up with the physical explanation for the virgin birth and the resurrection. So, after more than 3 decades of wrestling with this issue, I finally come to peace with an explanation. And it's interesting that a scientist has come around with an appeal to a miracle. And I'm okay with that. And I found many people are okay with that.
Well, Danny, this all makes sense to me. In fact, it even reminds me of the first miracle of Jesus. And if we were to try and take physics and all that we know about wine and try to understand how Jesus created wine in a very rapid moment, we wouldn't be able to do that.
No, and I think that underscores the fact that that science addresses the natural world, and miracles are supernatural. And so you can't use a scientific method to discuss miracles, I don't think.
Well, Danny, do you see any other evidences that would indicate that the universe is really much younger than what the traditional paradigm would tell us?
Yes, I do. For instance, spiral galaxies. The Andromeda Galaxy we talked about is a spiral galaxy. Our own is. It's a pretty common type of galaxy. In their disks, they have this spiral pattern made up of clouds of dust and gas and bright stars. And the inside of the galaxies should spin faster than the outside of the galaxy. So after a few rotations, you ought to wind up or smear out those spiral patterns. They ought to disappear after a few rotations. Now, most astronomers think that spiral galaxies are 10 billion years old. So why do we still see spiral patterns? You shouldn't see those.
Right.
And it's been long recognized as a problem. In the late 60s, they developed this thing called spiral density wave theory, and that was the answer for several decades. That they assured us that it worked, that there were these sound waves propagating through the galaxy that made these things persist. Well, then by the 90s, they were invoking companion galaxies that were stirring things up instead. And more recently, it's now been dark matter that's stirring these things up. So we've had, in the last 45 years, 3 different solutions to this problem. You don't need new solutions if the old ones worked, and they assured us that they did. So I think that's a problem. If we look at the outer planets of the solar system, the gas giants, they all have rings. You know, when we were growing up, only Saturn had a ring system, but now we know that the other 3 have them as well. And we also know that these things are changing, wiping out. We know theoretically they ought to, and with probes to Saturn and Jupiter, they've actually documented changes that have taken place within the ring system. You have all these gravitational tugs from the other satellites orbiting around, and people have estimated that a ring system like Saturn's can last maybe 1 million years or more, just a few million years, with an M, not a B. So these ring systems are fairly young. Doesn't prove the solar system is young, but it proves that these ring systems are young, and that's interesting. You know, in the summer of 2015, we got the first photos from the surface of Pluto, and the big shock everyone had, including me, was the fact that there's a lack of craters. There are a few impact craters, but not many on Pluto. Now, it's been doctrine for decades in the solar system that whenever you see lots of impact craters, it indicates a very old surface. And when you see very few craters, it's a young surface. You've had geological activity that's reworked it. And you can do that 3 different ways. Well, none of them work for Pluto. So it indicates that Pluto is a young object. It doesn't have any way to do this. Now they're trying to figure that out, how in the world in billions of years you can have a young-looking Pluto. Those are the kind of little interesting things that you see from time to time about the planets. We see evidence of rapid processes on the surfaces of planets. Venus, they believe, had a complete overturning of its surface in the not too distant past. They say like 150 million years ago, which is pretty recent in a 4.5 billion year history. But they think the entire surface of Venus was turned over in a very brief period of time, a million years or less on their time scale. Furthermore, you look at Mars. Secular scientists are saying that there was a global or near global flood on Mars, a place where there is no water today. They don't think that could have happened on Earth because, well, they don't believe it happened, but there's plenty of water here. And those are the kind of things indicating rapid processes, much more rapid than many people realize. So I think there is evidence out there. And my job as a creation scientist, as an astronomer, is to identify and discuss those and bring attention to them. And I intend to keep doing that over the years.
Sure. That brings us to what most people see as the big theory concerning cosmology and the universe, and that's the Big Bang. How do you see that? Is it holding up over time?
I don't think so. I think it's getting some problems. You know, I reject it because I'm a biblical creationist, and I don't see any way that you can reconcile Big Bang with the Bible, though a lot of people seem to think that you can. I think the temptation they have there is to try to interpret Scripture in terms of the current cosmological thinking. That's nothing new. That's happened before, as it's turned out, with disastrous results. But I like to compare the Big Bang model to the ruling cosmology of the Middle Ages, what we call the Ptolemaic theory. A man named Claudius Ptolemy around the early 2nd century A.D. developed this theory to explain the motions of the planets. As the planets orbit around the sun, and we orbit around the sun too, it makes for a very complex motion. The planets, as well as the sun and the moon, seem to move in a west to east direction along the ecliptic, the plane of the Earth's orbit around the sun and solar system, actually the plane of the solar system. But from time to time, the planets reverse direction. They go from west to east, back to east to west. We call it retrograde motion. And that was difficult to explain if you think the Earth is the center of things, the geocentric theory like the ancients did. So what Ptolemy came up with is this very complex model where you had a planet not just orbiting around the Earth, but you had it orbiting on a smaller circle we call the epicycle, and the epicycle in turn went around the Earth, and if you adjust the sizes of those two circles and the speeds, you can end up with this motion like this where the planet seems to move backwards. And this was the ruling cosmology for 15 centuries, from really the 2nd century up through the 17th century. Now, as new data came along and problems developed so that you had a discrepancy between the theory and the data, they simply altered the theory, added more epicycles to make the theory work and fit. That was the strength of the model, that you could adjust it to fit anything new that came along. Well, it was also the undoing, because it became very complicated. By the year 1600, there were systems of more than 100 epicycles. You had gears on gears on gears on gears, and people realized this is way too complex, and finally it was rejected. And the Big Bang has done the same thing. It's been the ruling paradigm for 50 years, and in that length of time, I've seen tremendous changes take place. You know, in the early 1980s, we had this Big Bang model that seemed pretty mature, and they were convinced that this Big Bang model was true. But since then, a lot of changes have taken place. They changed the expansion rate of the universe, which decreased the age from 16 to 18 billion years to 13.8 billion, plus or minus 1%. They've introduced string theory into the model. This is the thing dealing with particle physics you have to put in. They've introduced dark matter. They've introduced dark energy. They've introduced this idea of cosmic inflation, that the universe expanded very rapidly in the early universe to solve a couple of problems that they have. By the way, there's no evidence for inflation, but everybody believes it happened because basically we're here, aren't we? I've seen in my adult lifetime numerous changes taking place to the Big Bang theory, and it's starting to look like epicycles. It's starting to look like the Ptolemaic model, just as the strength of that model was that you could change it to fit new problems in data. They're doing the same thing with the Big Bang and changing it. You know, they had the Kobe experiment in 1989 to 91 that was measuring little fluctuations in temperature predicted in the background radiation, the supposed proof of the Big Bang. And they had predicted fluctuations in temperature from point to point of 1 part in 10,000. Well, they found fluctuations 1 part in 100,000, a factor of 10 less. And afterwards, they said that the predictions and the actual measurements beautifully agreed. Saying, wait a minute, how can that be? What they did is they changed the model to fit the data once again. You know, if you have rules like that, you can never disprove a theory. One of the fundamental assumptions that the Big Bang is based upon is that there's a homogeneity of the universe, that it's kind of smooth. It makes the mathematics work out easier, by the way. And we recognize that on the local level, it's kind of clumpy. We have planets and stars and so forth, but then you have galaxies, and then you have groups of galaxies and galaxies working their way up. And it's kind of assumed that on the biggest scale that sort of smooths out. But what we found over the last 35 years is that this clumpiness goes up to the highest levels. It's kind of shocking when they begin to realize that. They don't talk about it much anymore. But the problem is we're now really poised to make what we think is the structure of the universe on the grandest scales, and it's clumpy all the way up. And what most people have failed to realize is this negates the very foundation upon which the Big Bang is based. The assumption of homogeneity. It's not homogeneous anywhere. It's been an article of faith that at some level it is homogeneous, despite all evidence to the contrary. And we're seeing it on the giga light year scale now. It's across the entire universe. And so the Big Bang has become the ruling paradigm, and it's becoming doctrine. It's becoming dogma. So much so that more than a dozen years ago, I think in the New Scientist magazine, there was an open letter protesting the Big Bang theory, and it's had hundreds of signatories since. And most of the people signing it are atheists. They're not even creationists. Right? So this idea that the Big Bang model is universally accepted is not true. There are many people out there, well-known people, very famous physics and astronomy people, that have real problems with the Big Bang. So I think when you look at the history of science, the way we've discarded theories over time, you've had theories that were supposedly beyond dispute, and then later on discarded. When you see that lesson from history, and then you want to wed Genesis, you want to interpret Genesis in terms of the ruling paradigm, I think you need to be very careful.
Sure. Yeah. Well, all of this, Danny, just brings me back again to the awe associated with all that God has done, the immensity of it.
Yeah. You know, we've been out here quite a while, and the summer stars have kind of gotten out of the way, and the autumn stars have moved across. We're now getting a lot of winter stars up here, and I want to point those out to you. You know, one of my favorite constellations up there are Orion. Do you know Orion? That's a really good one. But it's also mentioned in the Old Testament 3 times, twice in Job and once in Amos. You know, when I look up at Orion, I'm seeing about the same thing Job saw, because those stars are hundreds of light years away, and even though they're moving, they haven't changed in 4,000 years, really. The shape is about the same. But you know, there's a connection I can make to a man that's been gone for thousands of years. But more important than that, of course, is that I should make the connection to our Creator, because God was challenging Job about the fact that he created all of these things.